Good morning, dear student. We're having our lesson in chemistry this morning. We are doing this because of this corona issue. So there's no way that we can keep you home without teaching you. We're trying by all way to give you the lesson right at your bed. So in Form 4, we ended with the transition element. And that's where we're going to start this morning. Now, what is transition element? Transition elements are those elements that are found in between group 2 and group 3. Group 1, 2, 3 are metals, and transition elements are also metals. Now we have the first series of the transition metal. We have the second series and the third series. Now in Form 5, we are concerned with the first series of the transition metals. We also call them the D block element. Why do we call them the D block? They are D block element because the outermost electrons are filled in the D orbital. An orbital is that region or is that space in an atom that you are certain to meet an electron. Now, you look at my periodic table. On this periodic table, I have the group 1, which we call them the alkali metals. We have the group 2, we call them the alkaline earth metals. Group 3 does not have any special name. 4, 5, 6, 7. And the group 7, we call them the halogens. Why do we call them the halogens? We are calling them the halogens because when this group 7 element react with any metals, it forms salt. So the group 7 elements are salt producers. That is the reason we call them the halogens. Now we look at the group 8 element. We have neon and argon are the group 8 element. We classify them as group 8 because their valence electron, that is the last shared electrons, are found in R8. Their last electrons are stable. When element has 8 electrons in the outermost shell, the element does not react. The element is stable. That is why group 8 elements are stable, and we call them the noble gases or the group 0. Now, you look at, we have P1 here, P2, P3, and P4. This P stands for period. It means that hydrogen is period 1. Lithium, beryllium, boron, carbon are period 2. Sodium, magnesium, aluminum are period 3. And potassium, calcium are period 4. They are grouped in period depending on the number of shells that they contain. For example, sodium, I have 2, 8, 1. How many shells do I have? This is the first shells, second and third shells. Since it has 3 shells, we put it under period 3 because of these 3 shells. Magnesium, the same, atomic number 12. I have 2, 8, 2. Discover that it has 2, the first shell, 8, the second, and the last shell. Since it is 1, 2, 3, we put it under period 3 because of the 3 shell. And group 2 because of these last electrons in the shell. Okay, we're going to look at the characteristic of transition element. Before we go to that, I had labeled here S block, D block, and P block. S block are the group 1 and 2. We put the S block because their last electrons are found in the S orbital. D block, their last electrons are found in the D orbital. And P, their last electrons are found in the P orbital. Remember, I said that an orbital is that region, is that area in an atom that you are certain, you have high probability of meeting an electron. We call them orbitals. Now, under transition element, you are going to look at their characteristic. They are all metals. The same like group 1 and group 2. They are metals. Even group 3 are metals. What are their difference now? What is the difference between transition element and group 1, 2, and 3? Since all of them are metal, we're going to look at those differences. They form a colored compound. For example, potassium permanganate is purple. It's a compound. Manganate is a transition metal, which is formed by combining with potassium and oxygen. It gives a purple color. That is a general characteristic of the transition element because they form a colored compound. We have the variable oxidation state. Like group 1 and 2, their oxidation states are fixed. Group 1 has 1 oxidation state. That means that the electrons in the atmosphere are 1. So it makes up their oxidation state or their valency. So here we have ion 2 plus, ion 3 plus. It means that the oxidation state vary from ion 2 to ion 3. That's the most important characteristic of the transition element. Most of them are catalysts, or they act like a catalyst. For example, vanadium pentoxide acts like a catalyst when we are producing sulfuric acid in an industry. When sulfur dioxide reacts with oxygen to give sulfur trioxide, we must use vanadium pentoxide like the catalyst. It facilitates that reaction. A catalyst is a biological substance that facilitates the rate of a chemical reaction. It makes reaction to go faster. We have nickel. Nickel also acts like a catalyst where we are reacting ethane plus hydrogen to give ethane. That is the production of alkane. That is under organic chemistry. When we get to that, we'll learn more about it. We have iron. Ions act like a catalyst when we are producing ammonia industrially. Nitrogen plus hydrogen to give ammonia. And the catalyst that we must use there is iron at a certain range of temperature and pressure for the reaction to go faster. We also have, it forms a complex ion. For example, I have, this is 4, this is ammonia, and this is copper. Now, 4, we call it tetra. In this form, we call this ammonia amine. Tetra amine copper 2 ions. That is a characteristic of a transition element. Okay, today we're going to end here, but before I leave, I'll give you some assignment that you must do and send it to me over my WhatsApp. 1. State any 2 compounds that are colored. I mean the transition element. 2. Write an equation to show where any transition element is acting like a catalyst. 3. List all the elements of the transition element. Write all the 10th element, that is the first series of the transition element. 4. Why do we call the group 7 element the halogens? Thank you, and make sure you do the assignment, please. I am begging all of you because I know that you don't have time. Do it, it's for your good. Have a wonderful day. Thank you again.